Download this code from codegive.com, link in the description below. OK, let's dive deep into the infamous Count Dooku expose weakness bug in Star Wars Battlefront 2, 2017. This bug was a long-standing issue that affected Dooku's gameplay significantly, particularly regarding his damage output and survivability. We'll cover the bug itself, its impact, attempted fixes, both official and community-driven, and how it might have been implemented within the game's code structure, based on educated speculation, as we don't have access to the actual DICE source code. Important disclaimer: I cannot provide actual decompiled source code or hack the game. This explanation uses pseudocode and conceptual examples to illustrate how the bug could have arisen based on observed behavior. We're going to talk about what the bug was and how it likely functioned, not how to exploit it. The expose weakness ability, what it's supposed to do. Count Dooku's expose weakness ability is a core part of his character design in Battlefront 2. The intended functionality is as follows. 1. Activation *, the player activates the ability. 2. Target lock, or cone. Dooku targets an enemy unit, either by locking onto them or through a cone-shaped area in front of him. The UI should indicate the target is properly selected. 3. Debuff application *, the targeted enemy receives a debuff. This debuff is supposed to have several effects. Increased damage taken *, the primary effect. The enemy should take significantly more damage from Dooku's attacks for the duration of the debuff. Animation / VFX * a visual effect, VFX, would typically appear on the enemy to indicate they are debuffed. Sometimes a sound effect, SFX, will also play. Duration *, the debuff lasts for a specific duration, example 5 seconds. 4. Cooldown *, the ability goes on cooldown after activation, preventing immediate reuse. 5. Ability cancel / break *, the ability could be manually cancelled before activation. 2. The core of the bug, the damage amplification issue. The expose weakness bug manifested in several ways. Inconsistent debuff application *, sometimes, the debuff wouldn't apply to the intended target at all, even if the UI indicated a successful lock. Incorrect damage amplification *, the damage amplification provided by expose weakness was not what it was supposed to be. It might be lower than expected, or at times, unintentionally made him do far more damage than he should. Survivability issue * Count Dooku would sometimes take more damage than normal when his expose weakness ability was activated. Targeting issues * the ability would not target who it was intended to, or sometimes, nothing at all. Ability cancellation issues * activating other abilities would sometimes incorrectly cancel expose weakness, causing it to not function as intended. 3. Why this bug was so problematic. Unreliable damage output * players couldn't consistently rely on expose weakness to deal amplified damage. This made Dooku's damage output inconsistent and frustrating. A critical part of his character's strategy was rendered unreliable. Character weakness * if the ability was ineffective, Dooku, already a character requiring skillful play, became significantly weaker compared to other heroes. His viability was negatively impacted. Frustration and unfairness * the inconsistent behavior led to player frustration, especially in competitive modes. It felt unfair when the ability didn't work as intended. 4. Hypothetical code structure and potential causes, pseudocode. Let's imagine the code structure for expose weakness might look something like this, simplified, of course. Possible bug origins, based on the pseudocode and observed behavior. 1. Targeting logic errors *. Asterisk the activate_expose_weakness function might have had flaws in how it identified and validated the target. For example, asterisk incorrect distance checks. Dooku might have needed to be within a very specific range for the target to be considered valid, and this range might have been too small or inconsistent. Asterisk obstruction checks. The code might not have correctly accounted for obstacles between Dooku and the target, leading to failed target locks even when the target was visually in range. Asterisk target priority. The targeting system may have prioritized non-enemy objects instead of actual enemies to lock onto. Asterisk the targeting logic might have been using incorrect or inconsistent coordinate systems, leading to misidentification of the target's position. 2 debuff application failures asterisk. Asterisk even if a target was identified, the debuff might not have been consistently applied. Asterisk race condition asterisk the debuff application could have been subject to a race condition, where other game systems interfered with the process, causing it to fail intermittently. Imagine 2 parts of the code trying to modify the same target property simultaneously. Asterisk missing network synchronization asterisk in multiplayer, the debuff application might not have been properly synchronized across the network, leading to inconsistencies in what different players observed. Asterisk incorrect flag setting asterisk the self.expose_weakness_active flag could have been set incorrectly, preventing the damage amplification from being applied even when the target was debuffed. Asterisk duration issues asterisk if the duration was linked to real time, instead of game time, latency would impact the length of the ability. 3 damage calculation errors asterisk. Asterisk the attack function might have contained errors in how the damage multiplier was applied. This could have led to the damage being lower than expected, or, in some cases, far higher, if the multiplier was accidentally applied multiple times. Asterisk order of operations asterisk the order in which damage modifiers were applied could have been incorrect. Asterisk floating point errors asterisk floating point calculations can sometimes lead to subtle inaccuracies, which could have compounded over time, resulting in unexpected damage values. Asterisk integer overflow asterisk if the damage value became too large, exceeded the maximum value for an integer, it could wrap around to a negative value or a small positive value, leading to drastically incorrect damage. 4 conflict with other abilities asterisk. Asterisk Dooku's other abilities, example lightning stun, might have interfered with the expose weakness debuff. Asterisk the update function may be responsible for prematurely cancelling the ability. 5 Dooku taking more damage asterisk. Asterisk Dooku was known to sometimes take more damage than intended. This was probably done intentionally, but caused an error in implementation. Asterisk vulnerability timer asterisk the timer might not be working as intended, causing Dooku to be vulnerable for longer than he should be. Asterisk activation issues asterisk the ability to activate the vulnerability might be linked to the wrong trigger, causing him to take more damage than intended in unexpected circumstances. V potential fixes and mitigation, theoretical. Based on the hypothetical causes, here are some potential fixes DICE could have implemented. 1. Robust targeting logic asterisk. Asterisk implement thorough distance and obstruction checks in the activate_expose_weakness function. Asterisk use raycasting to ensure a clear line of sight to the target. Asterisk prioritize enemy targets over non-enemy objects. 2. Reliable debuff application asterisk. Asterisk use atomic operations, if the engine supports them, to ensure that the debuff is applied consistently, even in the presence of other game systems. Asterisk implement proper network synchronization to ensure that the debuff is visible to all players in a multiplayer match. Add robust error handling and logging to detect and diagnose any failures in the debuff application process. 3. Accurate damage calculations. Carefully review the damage calculation logic to ensure that the damage multiplier is applied correctly and only once. Use appropriate data types, example double precision floating point, to minimize floating point errors. Implement checks to prevent integer overflows. 4. Ability conflict resolution. Carefully manage the interactions between Dooku's abilities to prevent any conflicts or interference. Consider using a state machine to manage ability states. Ensure that the expose weakness debuff is not prematurely cancelled by other abilities. 5. Thorough testing. Conduct extensive testing with different game modes, maps, and player counts to identify and fix any remaining issues. Solicit feedback from the community to help identify edge cases and other problems that might not be caught by internal testing. 6. Community fixes, mostly psychological. In the absence of official fixes for extended periods, players often develop coping mechanisms or strategies to try to mitigate the impact of bugs. These are often anecdotal and may not provide a true statistical advantage, but rather a sense of control. Manual aiming. Some players found the ability was more likely to work if they manually aimed and activated the ability precisely when their crosshair was centered on the target. This likely wasn't a true fix, but more of a psychological attempt to regain control. Specific target types. Players might have believed that the ability worked better against certain types of enemies, example heroes versus troopers. This could have been based on anecdotal evidence or selective memory. 7. Lessons learned. The expose weakness bug in Battlefront 2 serves as a cautionary tale about the challenges of game development and the importance of thorough testing. Comprehensive testing is crucial to identify and fix bugs before they reach players. Robust code. Well-structured and well-commented code is easier to maintain and debug. Community feedback. Listening to the community is essential for identifying and addressing issues that might not be caught by internal testing. Transparency. Open communication with players about bugs and fixes can help manage expectations and reduce frustration. 8. Why the bug persisted. Speculation. Several factors might have contributed to the persistence of this bug. Complexity of the game engine. Game engines like Frostbite, which Battlefront 2 uses, are incredibly complex, making it difficult to isolate and fix bugs. Resource constraints. Development teams often face tight deadlines and resource constraints, which can limit the amount of time and effort they can dedicate to fixing bugs. Prioritization. Game developers must prioritize bugs based on their severity and impact. The expose weakness bug might not have been considered a high priority issue compared to other, more critical bugs. Underlying architecture issues. The core of the ability was intrinsically flawed in some way, making it difficult to fix without a major overhaul. In conclusion, the Count Dooku expose weakness bug was a significant issue in Battlefront 2 that affected his gameplay and overall viability. While we don't have access to the source code, we can speculate about the potential causes based on observed behavior and general game development principles. The bug highlights the challenges of game development and the importance of thorough testing, robust code, and community feedback.